Welcome back, everybody, for another deep dive. This time, we're going to be checking out some seriously fresh research, talking like just published a couple days ago stuff. It's all about wearable tech, but not the Fitbit kind. We're going even smaller, get this, wearable tech for your brain cells.
Yeah, you're not kidding. It's pretty mind-blowing. I mean, just think about it. Trying to mess around with individual brain cells, neurons, these things are so delicate, and they've got all these crazy branches and shapes. So you need a device that's not only going to make contact with them, but also, like, fit all those weird shapes.
That's what really hooked me on this whole thing, the creativity of it all. It's like they said, hey, what if we miniaturized wearable tech and stuck it on a neuron?
It's kind of like trying to fit a square peg in a round hole, you know. Even the smallest electronics are still too stiff and clunky to work with something as delicate as a neuron. I mean, without just destroying it.
But this new research, they found a way around that. These scientists at MIT made these teeny tiny wireless devices. We're talking smaller than a human hair here. And they're made out of this special material called azobenzene. And the best part, they're designed to wrap around the neuron, not poke into it or anything.
Yeah, that's a big deal. That whole wearable idea makes it way less invasive, so it's much safer for the neuron. It's like opening up a whole new world for figuring out how the brain works and maybe even treating neurological diseases, all at the cellular level.
Okay, so how do these micro devices actually work? This is where the science gets super cool. Azobenzene has this crazy ability. It changes shape when you shine a light on it.
Yeah, it's pretty slick.
Yeah.
By tweaking the light, like how bright it is and stuff, they can make these devices roll up, almost like a little scroll. And then they fit snugly around those neurons, even the tiny little branches. It's kind of like, imagine trying to wrap a piece of paper on a single hair. That's how precise we're talking.
No way. And get this, they figured out how to make tons of these things without needing a fancy lab. They basically put a drop of this azobenzene stuff on a special surface. Then they use a stamp to make the shapes they want, like little rectangles or even like flowers. Then they get rid of the extra material and bam, thousands of these micro devices just floating around, ready to be used.
The fact that they can pull that off, all that precision and complexity with such a simple process, it's amazing. And it can make this tech way more accessible in the future, which is super exciting.
So now we've got all these tiny flexible devices that can wrap around individual neurons. But what can we actually do with them? Well, these researchers have a couple big ideas, and they're both game changers. First up, synthetic myelin.
Now, if you're not a brain expert, myelin is basically this fatty stuff that wraps around neurons. It acts like insulation, helping signals travel faster.
Yeah.
But diseases like multiple sclerosis, they mess up the myelin. And right now, there's no way to fix it.
And that's where these devices come in. They can act like replacement myelin, wrapping around those damaged neurons and maybe even restoring their function.
Yeah, this could be huge for treating those really tough neurological diseases. Imagine being able to help people with MS by literally rebuilding the insulation around their nerve cells.
And that's just the beginning. If you combine these devices with other materials, they can become tiny circuits, ones that can both sense and stimulate the neurons.
So you're talking about measuring what individual brain cells are doing, or even sending targeted signals to them.
Exactly.
Wow, the possibilities are endless. We could finally figure out how the brain really works and maybe even develop completely new treatments for stuff like Parkinson's or epilepsy.
It's incredible, right? And we got to remember, this is all still really early research. But the potential is massive.
Totally. We're talking about a whole new way of looking at and interacting with the brain. This could change everything about how we treat neurological diseases, understand how the brain works, maybe even boost our brain power in the future. Who knows?
So why should you care about all this? Well, because this research is a giant leap forward in figuring out how to work with the most complex organ we have, the brain, and that affects all of us.
Yeah, if you think about the big picture, it shows how fast science is moving and how much potential there is to improve human health and understanding.
We've covered a lot already, but there's so much more to this story. So let's dive a little deeper into how they make these devices and how they might actually use them in the brain.
You know, I was really impressed with how they made the whole manufacturing process so efficient. It's actually pretty clever.
Yeah, it's like you're making thousands, maybe millions of these microscopic devices. How do they do that without, like, living in the lab?
They use this cool trick called a sacrificial layer. Imagine building a sandcastle on a platform of ice. You make all the fancy details on top of the ice, and when you're done, you just melt the ice away.
So it's like a temporary base.
That's so smart. Exactly. In this case, they put the azobenzene polymer on this special layer. use a stamp to make the shapes, and then just dissolve the layer. You're left with all these perfect little micro devices floating in liquid.
It's like a microscopic cookie cutter.
Yeah.
And because they can use different stamps, they can make all kinds of devices. Like each one could be made for a specific job.
That's what makes it so powerful, that flexibility. You could design devices that are perfect for wrapping around different types of neurons, or ones that carry different sensors or stimulators. The possibilities are kind of crazy.
Okay, so we've got our tiny shape-shifting devices ready to go. But how do they get them into the brain? We're not talking about brain surgery, are we?
No, nothing like that. They're thinking about a much less invasive approach. They think you could just inject a bunch of these devices into the brain. Because they're so tiny and flexible, they can move through all those blood vessels without causing any problems.
So they just kind of float around in the brain?
Basically, yeah. And once they're where they need to be, they can be turned on using light. Think of it like a remote control for your brain cells.
Whoa, hold on. So you shine a light on the brain and these things start working.
That's the idea. And
Yeah.
because light can go through tissue, you could do it from outside the body. It's wild. Imagine being able to make certain neurons fire or see what they're doing just by shining a light on a specific part of the brain.
Okay, now I'm starting to get why everyone's freaking out about this. But even though it's super small, injecting anything into the brain kind of freaks me out.
Right.
What about the risks?
I get it. It sounds scary. But these researchers have been super careful. First off, they picked a polymer that's biocompatible, which means it won't cause any bad reactions or damage in the brain.
That's good to know.
And they've done a ton of tests to make sure the devices are safe and work like they're supposed to. Remember, they already successfully wrap these things around rat neurons without hurting them at all. Plus, because they're wireless and don't need batteries, there's no chance of them overheating or leaking chemicals.
So there's always some risk with anything medical, but it sounds like they're doing everything they can to be safe.
Oh yeah, definitely. And with any new tech, especially something that messes with the brain, there's going to be a ton of testing and safety checks before they ever use it in humans.
Makes sense. But even with all that, I think we got to talk about the ethical side of this tech. We're talking about devices that can directly interact with our brains, the source of our thoughts, memories, everything that makes us, us.
That's a really important point. This tech brings up all sorts of questions about privacy, control, even what it means to be human. I mean, if we can make specific neurons fire to change someone's mood or behavior, who decides how that power is used? And what happens if it gets into the wrong hands?
Yeah, those are some heavy questions that we need to start thinking about right now. Before this tech gets out there, we need to have open and honest conversations about the good and the bad, and come up with clear rules for how it should be used.
Absolutely. This is powerful stuff, and like any tool, it can be used for good or bad. It's up to us to make sure it's used responsibly. And that's not just on scientists and politicians, it's on everyone.
It's like we're on the edge of something totally new. There's so much potential for good, but also a lot of risk. We need to be careful, but also excited.
Yeah, it's definitely a lot to process. I mean, with all this excitement and these big questions, we got to remember that this is still early days.
For sure. There's a long way to go before these little devices are actually used to treat diseases or, enhance our brains.
What kind of stuff needs to happen?
Well, first off, they got to figure out how to make a lot more of these things. Right now, they can make thousands. But to actually use them, we're going to need millions, maybe even billions.
Sounds like a pretty big challenge.
It is. And then there's the whole issue of getting them to the right spot in the brain. I mean, they've made progress, but it's still not perfect. And then, of course, there's the whole safety and effectiveness thing long term. We got to make sure these things aren't just safe to put in, but that they keep working for years, maybe even decades.
All good points. But even with all those challenges, I'm still optimistic. The fact that they can make these things without a clean room is huge.
How so?
Well, it means it could be way cheaper to make them so more people could actually use them. That's a big deal if you want to take this from the lab to the real world.
Yeah, I get it. The easier it is to make them, the more people they can help.
Exactly. And what really gets me excited is that this tech might not just be for treating diseases. Maybe we could use it to stop them from happening in the first place.
So instead of waiting for someone to get sick, you could catch it early and intervene.
That's the dream. For a lot of neurological diseases, the earlier you catch them, the better. And beyond treating and preventing diseases. Who knows, maybe we could even boost brain power in healthy people.
Okay, now that's where things get really interesting. Are we talking like better memory, focus, creativity?
You got it. Imagine being able to tweak brain activity just a little bit to help people think better. Of course, this is still just an idea, and we need to be careful. The brain is complicated, And if you want to mess with it, you got to really understand how it works.
No brain hacking. But
Yeah.
seriously, it's pretty mind-blowing. Makes you wonder what the future holds for this technology and for brain science in general.
For real. We're just getting started.
Well, I think we've covered a lot today. We talked about the science behind these tiny devices, what they could be used for, even the ethical stuff. It's clear that this technology could totally change how we understand the brain and how we treat neurological diseases. But there are also some big challenges and ethical questions that we need to think about as this all keeps developing.
Absolutely. This is a future we'll be shaping together.
So to wrap things up, I'll leave you with this. What other possibilities do you see for this tech? What excites you? What worries you? Think about it, because the future of brain tech is being written right now, and we all have a part to play